recording. So, good evening, everyone, and thank you for joining us for tonight's sustainability lecture series entitled Ecological Sentinel. Before we proceed, let's begin with a short prayer.
Let me be the change I want to see, to do with strength and wisdom all that needs to be done, and become the whole that I can be. Set me free from my fears and hesitation. Granting courage and humility. Fill me with spirit to face the challenge and start the change I long to see. Today I start the change I want to see. Even if I'm not the light, I can be the spark. In faith, service, and communion, let us start the change we want to see. The change that begins in me. Today I start the change I want to see.
Even if I'm not the light,
I can be the spark. Service and communion. Let us start the change we want to see. The change that begins in me.
Jesus in us.
Jesus in us.
Okay, now to give us a brief overview of what the sustainability lecture is all about, let us welcome the Vice President for Research and Innovation of De La Salle University, Manila, Philippines, Professor Raymond Tan.
Thank you. Thanks very much. Good morning, good afternoon, and good evening to everybody. Thank you for being here. I want to say a few words about the sustainability lecture series, which we originally launched in January of 2021. The lecture series is a joint initiative of De La Salle University and the International Association of La Salle Universities, a global network of La Salle institutions spanning multiple continents. In January 2021, we launched this series to provide a platform for sharing of information across the network and with our partners and stakeholders. This was also intended to provide opportunities to create linkages throughout the network and perhaps open up collaboration opportunities that we would not normally have. The series was originally launched by a core group of people consisting of our host and the lead person, Professor Kathleen Aviso, the Dean of Engineering, Dr. Carmelita Kepenko, the Chancellor Emeritus of De La Salle University, and Professor Alvin Colaba, the Director of the Center for Engineering and Sustainable Development Research. As this series has gained traction for nearly 5 years, we have partnered with the University Sustainability Office, represented here by Mr. Riadel Masilungan, and headed by the Executive Director, Antonio Carlos Maralit, who isn't with us today, but the University Sustainability Office takes care of the logistics and the arrangements for the conduct of this lecture series. But most of all, it is a series that is inspired by events from 10 years ago. The late Pope Francis's encyclical Laudato Si, which encouraged all of us to examine and to explore greener lifestyles throughout the world. And at the same time, in the same year, the United Nations Sustainable Development Goals, which provide a comprehensive roadmap for human development across the entire world. I'm happy to note that this lecture series is going strong. We even have a dedicated YouTube channel where recordings of most of the lectures are made available for delayed viewing. But of course, tonight, I'm happy to note that we have a speaker, Dr. Alan Briones, to share his project with the audience. Thank you, and thanks to everybody who have supported this lecture series for so many years.
Thank you so much, Professor Tan. So tonight, we'll hear about the EcoSentinel project, which envisions a groundbreaking transformation in our relationship with nature to address pressing global sustainability challenges as biosphere integrity degradation, fostering a harmonious coexistence between technological innovation and environmental conservation, culminating in a community of ecological sentinels. The EcoSentinel project proposes a new form of plant-to-plant interaction by elevating it to a digital level. By enhancing plants' interconnection through cybernetical implants, we embark on a path to digitally transform the greenery. The unprecedented approach aims to establish a novel wireless plant-based communication system which uses plants as natural antennas, uniquely powered by the integration of plant-microbial electricity generation seamlessly blended into the vegetation. Our speaker for tonight is Dr. Alan Briones, who holds a PhD in Information and Communication Technologies from LaSalle Campus Barcelona Ramon Llull University. His research is focused on the Internet of Things and its impact on different application fields such as e-nature, health, Industry 4.0, and the like. He is the coordinator of the Blended Network Architectures area in the research group on Smart Society and has coordinated research, forecast, and feasibility studies for ICT infrastructures at the local, national, and international levels with more than 10 years of experience in several research projects related to digitalization. So please join me in welcoming our speaker for tonight, Dr. Alan Briones.
Hello, good night. Here we are midday, but good night. Nice to meet you. Thanks for joining this session. Thanks for inviting me. Thanks for everything. I think this is a nice opportunity to bring you what we have been working in the last years, and concretely in the past year about this project and other projects related to sustainability. And well, first of all, thanks for inviting me. My name is Alan Briones. Thanks for the opportunity. I have studied here in the university, La Salle Ramon Llull University in Barcelona, since the last 20 years. I have studied, my background is telematics. Okay, it's related to the communication, all the protocols that make the internet work. Also, I have the MSc in telecommunications and project management, which makes me a bit hybrid profile. And finally, I finished my PhD on the 2021. I've been leading the blended network architecture research line for the last 7 years, more or less. I've been very focused on the Internet of Things, Internet of Everything, also in terms of cybersecurity, but mainly I've been focusing on future networks. I participated in all kinds of projects related to IoT, Internet of Everything in different application fields, and that's why makes the our research line very traversal. We have been working in different fields, but at the end is the communication part, which is our point. So, thanks to this experience, also I can bring this to the classroom, no? Thanks to the teaching classes that I'm involved. Local area networks, integration of area networks, also project management. I have been tutoring a lot of final degree thesis. Also, I have PhD candidates with me. So, it's been a while since I started in the here in the university, and I'm glad that the university mm, gave me the possibility of growing and trying to make the world a better place at the end. That's why we built or we proposed the BNA, the blended network architectures. We are very focused on the cutting edge technologies. We want to make the difference to facing us the big societal challenges. And we are very focused on the brand new application fields like smart cities, in nature, in health, Industry 4.0. But here the idea is how, from the communication perspective, can we help the society, the world that is surrounding us? So, given the constrained situations, as we are going to see today, that they are very, very constrained situations, circumstances, given, for example, creating a plant, being a digital node communicating, this provides or brings us different constrained situations on, availability, bandwidth, energy source, no? If the plant is going to be giving the energy for the communication, we have all of us used a mobile phone with a big battery. The idea is not using a battery. So, constrained situations, circumstances that are going to put us in a context that we have to optimize what we are going to transmit through the nodes, through the communication system. And also, without forgetting the critical issues that we have seen through the news, all these cybersecurity possible attacks. So the part of the resilience, sustainability, reliability, and privacy, it's also something important. And what is something I think it makes us different is that we don't mind the nature of the community, if it's living creatures, if it's things. At the end is how we can improve the life of the living creatures. We say living creatures because it can be animals, it can be plants, it can be humans. We don't mind. The important thing is if we can make the difference. So, in order to provide you also perspective on the last projects that we have been involved, we had this Attica project, for example, very focused on e-health that we have been coordinators. Also, the little brother of the EcoSentinel, the green twin, everything started here with this little project. The idea was creating the digital twin, no, of a plant, and the plant itself, thanks to this digital twin, we were able to know when we need to water this plant without controlling as a human. Just with the sensors and the plant itself, it's going to warn us when we have to provide the water, for example. The NGSOC is one of the cybersecurity. I wanted to bring this in order to show you other possibilities, no, inside our research line. This next generation security operations centers is very focused on bringing new technologies related to the AI, no, the trending topic AI, with the idea of bringing new tools in order to confront big problems that can happen in companies, in institutions, organizations. The CoSentinel, let me talk about the CoSentinel, the last one, okay? And let me, I know it's not the objective, but the BTL COP project, it's a new project that we have been granted in the last months. The idea of this project is bringing a new tool, a new technology tool inside a big context of aporophobia, is bringing new tools for people who is in vulnerable situations. And the tool that we are going to be leading inside this project is a tool that allows us to locate people willing location. It's not the 24/7 that we have with the mobile phone. The idea is without a mobile phone, creating a device that allows the person in a critical situation, in a vulnerable situation, to press a button and someone, a trusting person, a trusting association, a trusting police, will come to this part of the city, to a specific location, and help this person. Here we combine different disciplines also, but the main idea is improving the life of these people in vulnerable situations in our streets, and at the same time reduce the increase of the aporophobia that is as isolating, affecting the society in the last days. I wanted to share this with you because we are very proud that we have this project, because we are going to make the difference directly on the society. And in terms of nature, we have the EcoSentinel. Okay, I'm not going to disclose specifically what happens with the EcoSentinel. So let me go directly to the project in terms of context. This project was funded on under the call Pathfinder Open 2024. At the end is the fundamental research calls that we have. In Europe in order to grant innovative. They talk about high risk, high gain projects. Okay, those projects that can be grown, but if they work, they are going to make the difference. It was submitted 1 year and a half ago. 1,110 proposals were sent and only 45 were granted. We were very lucky on this. We got a 15 over 15. It was granted in July, and it was a huge impact here in the university, in the research line, because you can see that from these 1,000 proposals, only 45 were granted, which makes a 4% success rate, which was very, very difficult this year. I think it has been 2,000 proposals in this 2025 Pathfinder Open. So it's a very complicated call to go, but I think it pays what you have to do in order to reach your success, no? And thankfully, we started on December 2024. We are currently in the month 11 out of 37. So we have covered a long path in the project, but uh, it's going to take a while to finally see, no, the co-sentinel itself. But we are in a good pace. We are in a good shape. We are achieving nice points. But what is EcoSentinel? EcoSentinel comes from a film that I have seen in the 2019 film by James Cameron. I took the advantage of showing you today because the hosts in Philippines, you will know about the El Nido, the nest. The film was inspired in one of these magnificent locations. I can imagine that some of you can know which is the film that we are talking about, but let me give you a bit more of information, because if we talk about the impact of this film, clearly impact 10 million individuals that were embarked on this journey to the moon of Pandora. Okay, we are talking, of course, about the Avatar film, this magnificent film that brought us to a new world with the navies, and I recall on one specific point of the film, and this was the way that we started thinking about the Eco Sentinel, bringing the reality of the last advances in the technology, and make dreams real. No, if we talk about, with James Cameron and we explain the idea of the Eco Sentinel, he will be like, "Wow." The idea is, if you recognize this part of the film in Avatar, we have this AWA as the central of a biological network where the Navi, the people, the creatures living in Pandora, they were able to connect to the forest, to the jungle, to the biological network hosted in Pandora. they were able to connect and live the experience of the forest. Why we made this, or why we thought about this? Because at the end is very similar on what we want. We want to get information from the forest and do the best for the forest. That was the objective of the Navi. If something happened in the jungle, in their environment, connecting with Ewa or the Tree of Souls, they were able to know what happened and what is happening in the forest. So what motivated us here in the university with my colleagues Joan Navarro and Agustin Zaballos, uh, it was this: is can we create this in our forest in the earth? It's possible or not? And we started to gather information, reading, and we arrived to the idea. No, it took us a while until we made it. This idea of, can we create a new form of plant-to-plant interaction by bringing it to a digital level? Of course, the plants, they communicate each other. That's why they don't collide at the top of the trees, no? And that's why they don't fight. They look for the food, no? With the roots under the moist, the soil. So they interact. The problem is that we are not able to be part of this information, this interaction. Well, that's why we proposed, or we started, no, to think about this crazy idea, because at the beginning it was a crazy idea, and now I really believe on this idea that we are going to be able to make it. Can we provide the plants cybernetical implants, always respecting the nature, the plants, the ecosystem, to transform the greenery and digitally connect with the plants, knowing how they are, their status, if everything is okay, and can we make it sustainable without batteries, without lithium? Can be the plant itself the communication system? That's what we wanted in the project, and as you can imagine, we need to provide something to the plants to be digital. No, we have our mobile phones, we have our wearables. As humans, we have a lot of sensors that can provide information about how you are or how you are sleeping. So if we can do it with humans, it's possible to bring this to the plants in order to, for example, avoid forest devastation, for example, or fires. Can we provide something to the plants in order to allow them to, hey, we need help from you, humans. Can you provide us help because there is a fire, for example, or we are in a dry season and we need some water in order to avoid to arrive to the cliff and die because the climate change, for example, and what was expected in terms of water, we are not getting it because it's not raining. So the idea is, can we create a novel wireless plant-based communication system? How we are going to do this? I'm going to explain it this night, but the main point is, can we use the leaves of the plants as antennas? This is one of the mind-breaking things that I was talking to our expert from here, Jaume Anguera, and well, it's possible. It's possible. The first experiments are providing us the first insights, and the idea is, can we use the leaf as a organic ground plane where we can transmit information? You can see in your mobile phones that there is no big antenna appearing on the mobile phone. Years ago, I remember my father. There was a big antenna in the mobile phone, and it was annoying. Now, the antenna is not visually appearing; it's inside the mobile phone. All the PCB, the board is used for the transmission. So thanks to have this, we are able to transmit information with the mobile phone. The problem is the creation of this epoxy is very bad for the world in terms of contamination, huge carbon impact, a lot of problems. The idea is, can we know a new way with organic systems that they work as antennas? That's the first point. The second point is where everything started with the can we get energy from the plant microbial interaction? We are talking about the processes of the plant being doing the photosynthesis, the release of the organics through the roots in the soil, and the microbes eating this food that the plant is generating. Can we capitalize this energy created by, well, created, no, it's you understand me. The idea is capitalizing all this process that can we provide this, can we get this and use this energy to transmit information with a radio, for example, that is connected to the leaf of the plant. So if we have to imagine this, or the way that we have envisioned is, can we put a plant microbial system for energy harvesting? Can we get energy from this interaction? And can we connect to a controller, a signal generation system, a radio? And this radio can use the leaf of a plant to transmit information for another plant, or other systems that are used by humans. So can we create a network, a nature-inspired network of different plants in a forest, in a jungle, in a park, in your garden? It's possible to connect plants that are self-sustained because they are generating the energy to provide power for this radio that is going to use the leaf of the plant to transmit information. Can we do it? It's possible, or no, or it's not possible. That's why it's groundbreaking, no? That's why this project is high risk, high gain, because if we can make it, we are going to provide a new vision of how we can take care of our forest. You can imagine a lot of applications. I will share with you at the end of the presentation different applications. But the most interesting thing is, if we have a network of plants all connected and we lose one plant, well, it can be an animal. It's okay. But if suddenly we start losing 1, 3, 6, 7, 10, something has happened. Maybe it's a fire, maybe it's a tree that has fallen. We don't know, but we have new information. We can use other sources of information, but this way is the plan itself providing information. So we can advance actions. For example, if we see that the plants are losing energy, for example, it can be a signal providing us information about what is happening in the plant. Because one of the most interesting thing is the system itself can be a living biosensor. With the information of the transmission, the energy generated, can we know the status of the plant? If it's okay, if something is not okay, something is very bad because the plant disappeared, so the system is not there anymore, and we cannot find this plant in the forest. So all this information that we are going to get from the system itself can be also important. Of course, if the plant is there, good. But if it's not there, something bad. But given the information that we are getting from the communication, can we have a living biosensor itself? So that's the idea. How we are going to make it? How we propose to do this? Well, it's not us alone, of course. It's not just La Salle Campus Barcelona. We have a huge experts. We have University of Genova. They are experts in plant physiologies, electrophysiology, biophysics, and environmental botany. We have also Planty. They are environmental biotechnology company. Okay, they are experts. They have the patent on this microbial electrochemistry technology. We have University Côte d'Azur. They are experts on radio. They are huge experts on this, and they are leading the part of the radio system. We have Ignion. They are experts on the part of the antennas. They have created the first experiment using a leaf as antenna. I will show you. Our site, La Salle Campus Barcelona, Ramon Llull University, we are leading the part of, as soon as the plants are going to be able to communicate, what they are going to say each other, how we are going to maintain this network. So we are on the part of what the plants are going to say in order to bring the information to the system. And finally, we have University of Trento. They are electromagnetic engineers. Engineering, they are experts on the part of biosensors, living biosensors. They are going to get all the information that we are going to generate from the different components, from the system itself, and they are going to be able to provide us how is the plant, the statute itself. So the approach, how we are aiming to create this, no? Because on the picture sounds nice, but well, as you can imagine, it's not going to be an easy path, and that's why we are here today. The status of how we are, the first insights, information that we have, new information which is not published for the moment, so it's going to be brand new for you, for the community. And the first approach, before we go to the four main components, I know that you want to know about them, but I need you to travel with me in the back to the past and how we started this when the project it was granted. How do you imagine that we can start the conversation? Do you think it was about, okay, each of us, let's work for it, let's make it. You are with the energy source, you are with the antennas, you are with the wireless communication system, you are with the living biosensors. See you in 3 years. Impossible. This is not the way that we are going to approach this interdisciplinary project. We need a lot of talking, a lot of workshops. We need to talk about how we are going to do this. So, the first thing that we have done was seminars. We have met on Wageningen in the Netherlands to talk, just to talk about each discipline. You have seen in the previous slide that we have people from a lot of disciplines, but how much information or which is the overlapping between the plant physiologies and botany and the part of the antennas? You can imagine. You can imagine we were closer positions, but the expertise from the people from the part from University of Genoa, for example, with the part of the plants and the part of the antennas, for example, they are two different worlds. It's very difficult to talk the same language. So we hosted different seminars, workshops, bilateral meetings. We worked hard on define the research requirements. It was our first deliverable is available on the website of the EcoSentinel if you want to check it. And we were able to define the context of the project. So it took us several months, few months, okay, to find the common language, the common understanding about the plants, the different traits, understanding the part of the antennas for the plants, the part of the energy for the plants, the good points, the bad points of the using antennas from the leaves, the part of the energy sources. So it was about connecting different components, but the main point, which is not appearing in bold but appears in the four components, is the plants itself. So our glue was the plant, our experts on University of Genova, and thanks to them, we were able to connect the organic world, the living world, with something which is with no soul, no nothing, which are the technological components, the chips, the antennas, the cables, all this technology that we are going to provide through cybernetical implants to the plant in order to digitalize this plant. So we had a lot of conversations, and I would like to highlight this point because on terms of sustainability, there is no specific discipline. So, from the terms of the project itself, I invite you all to talk to other disciplines, to understand, to know them. Why? Because at the end, you can learn a lot from the others and you can connect the dots that are not already connected, like this project. So, in terms of sustainability, there is no specific discipline or leading discipline. It's about understanding each other and finding the best way. So I want you to be the example of this interdisciplinary approach because thanks to this, we are able to achieve things that to be fair, 2 years ago we were not expecting to achieve or to be able to make it. So, if we go to the first component, the plant as energy sources, we have to talk about the plant microbial fuel cells. These plant microbial fuel cells, the idea is that thanks to the photosynthesis with the energy captured by the plants from the sun, we are well, we know the plants. Okay, we do another type of photosynthesis. No, the plants itself they release organic compounds through deposition, and thanks to this, we activate the microorganisms that are on the soil in order to to convert these to organics. Thanks to this and this technology that we are providing, we are able to capture this energy, this process, and capitalize in energy. You can see through the different diagrams. I have put different, you can choose, but at the end is thanks to this process that the plant is doing with the soil. So it's important the plant, it's important the soil and the microorganisms that are living on the soil because they are eating this food. Our experts from Planty, they talk about food. So let me talk about the food that the plant is releasing for the microbes, and the idea is capitalizing this process, capturing all the energy that is generated by the microorganisms eating this food on the soil, and capitalize with a good, it's not a huge power, this is not a battery, but with the idea of providing energy for the system. This is the plant as energy source. This is the main technology. Which is the main drawback of this technology? It requires a lot of water. It's for waterlogged systems. So the idea of the project is taking this to the next level. Here you can see an example of the power generated, okay, with a resistor of 2.2K ohms. The idea is, given the water temperature in this case, you can see that we are generating, the plant is generating around 0.1, 0.15 milliwatts, which is microbats at the end. It's possible to use this energy for the radio. We will see. Let's keep this and let's see how this goes. But in terms of technology itself, energy source, we can get energy from the plants. The main point of the project, let's try to make this work on non-waterlogged environments. Why? Because the world is huge. There are a lot of type of plants. We want to arrive to the full world. So the idea here is, can we create first of all, water retentive materials because we want to use this technology in different contexts. And the second thing, which was mind-breaking for me specifically, the root blocking. Because one thing is capitalizing the process, and the other thing is if the root is going to get the technology and break the anode and the cathode, and the technology is no longer working. Which is our objective or our key performance indicators? Stable operation, so it is working always, and achieve around 100 microwatts continuous output in order to provide energy for the radio. So the first component is clear, the energy source. We are taking advantage on this microbial activity given the food that is releasing the plant to the soil, and we want to capitalize with a very low power, but maybe enough power. The second point, where more or less everything started, was the part of the antenna. Our experts from Ignion, they started working on this antenna booster. Is one of the technologies from Ignion. The idea is, can we use a leaf of a plant to transmit? Objectives, measure the different plant traits. It's because of the water content that a leaf of a plant can be good. Is that the electric composition? Is the leaf shape? Which are the traits that we can capitalize in order to increase the power or the propagation of the waves that we are generating through through the leaf in order to arrive far away? Because the idea is covering a huge area. That's why they have done a first experiment with this little antenna. The idea was, let's try to use this antenna as it is, and let's try to put an aloe vera plant, concretely a leaf, attached, and let's see if we get what we want. Here we have the first result that we got, okay, from this. And what we have is that the antenna itself without the ground plane extension was around a 25% efficiency. And thanks to attach this leaf from the plant, we increase the double. 3 dBs is more or less the double of the efficiency. So thanks to this, to attach the aloe vera, we were able to see that the efficiency of the antenna was doubled. So this means that we can reach the double of the distance. If we measure, for example, or we use different leaf length, you can see that the length of the leaf can be also affecting the efficiency of this antenna. So the black line is the antenna without the organic compound, and as we increase the length of the leaf, the efficiency is increased. Of course, they are very preliminary experiments, okay? It was about cutting a leaf of aloe. So the idea is, can we, and we are connecting this with the unsolved issues, mysteries, can we find the optimal shape? Can we find which is the best thickness, the water content, how we are going to connect the PCB to the leaf? Because one thing is attaching directly, you have seen that from the plant perspective is atrocious. The idea is how we can put this antenna booster on the leaves without affecting or cutting them. Of course, we want to respect the plant life. And the last thing, which is the best plant species? And as you are thinking, or I can think you are thinking, can we find a plant which is good to generate energy, to provide energy, and at the same time be good transmitting with the antenna? Well, that's the idea. Finding it. The problem, well, you have seen that there are a lot of issues, mysteries that we want to solve. So with these two components, we go to the connecting one, which is the digital wireless communication system. The idea here is we have a very reduced amount of energy given the plant-microbial fuel cell, and the antenna is organic living thing. So we are limited because it's just organic. So can we develop a lightweight bio-inspired communication stack for plant-based networks? The first insight is we want to use a wake-up radio. These wake-up radios, the point of this way of working is they are ultra low power. So they can be sleeping, so the idle periods, and they can be wake up thanks to receive a signal from another plant. So the idea of using wake-up radios is we can use reduced amount of energy, and they can be activated with triggered or actions specific from the network. You can see here, for example, that we have a gateway that is activating one of the plants, and from this plant we can wake up the rest of the plants. Well, we have to talk about the part of the intermittent computing, no? As soon as I have enough energy, I can wake up and transmit to the other plants. As soon as I have sent the information, I can go sleeping again. As soon as I have energy, I can get up again. So thanks to this, we can save a lot of energy. In terms of sustainability, this is important because if we are sending a lot of signals, a lot of information, we are going to consume the energy received by the plant. This is non-disclosed info, but I'm glad to share with you that we have done our first experiments with the wake-up radios, and we have seen that it's possible to reach around 10, 13, 14 meters using the wake-up radio. So we can cover a range of around 10, 12 meters in order to wake up other plants. So this, the distance between plants in terms of EcoSentinel is around 10 meters. So thanks to this, given the status that we are in the project nowadays, we can be reaching 10, 12 meters. In terms of what the plants are going to say, it's important that yes, they are going to be connecting, they are going to be receiving the signals, but they have to discover the nodes that they have surrounding. They have to build the network in order to get the information, the data exchange, and bring it to the gateway, which is going to be where we are going to be looking at the system. And of course, as soon as they have discovered the neighbors, they have to do the keep alive. So we are still connecting. I have not lost the connection with you. You are okay. So we have to maintain the network. So from the green OC perspective, the communication stack, we need to also consider as soon as they are able to see each other and connect with the signal, what they are going to say each other in terms of the plants. And finally, we have the living biosensor part. We have two different points. From one side, we have the electrochemical impedance spectroscopy. The idea is, thanks to this information, we are going to infer the plant condition, and also the radio frequency metrics, the power that we are providing in terms of communication, because thanks to the RSSI from the plant, so the power that we are providing and receiving, we are going to be able to know how the planet is. We have set three different levels. It's okay, something is happening, something is KO. At the end, we want to correlate the impedance of the planet itself, okay? So how the planet is from the impedance perspective, and also the signal propagation. With this, we can link it with the stress and hydration of the plants, and we can infer how the planet it is in terms of living biosensor. The expected impact, or what we want, and with this I am finishing. First of all, can we create a bio-hybrid communication system? The plant itself can be a communicative node with the cybernetical implants. From the technological perspective, it's going to be the first carbon negative Internet of Things, Internet of Everything device, because the plant itself is a carbon negative, because we reduce the carbon impact for the fact of having a plant. So can we have a carbon negative system? From the environmental perspective, having autonomous ecosystems being monitored by themselves, and they can provide us the information without putting batteries, without entering or deeply entering on the system or the ecosystem. From the environmental impact, we can open a lot of new applications thanks to have these energy sources, this plant as antenna, and a system that can communicate given the low power received. And from the societal impact, of course, the green innovation that we are going to inspire, and the awareness of taking care of the plants, because you are going to be able to see how your forest it is, thanks to this information that we are going to be gathering. So you can see, yes, the greenery itself, but also from the digital level, you can see how it is. Potential applications, carbon accounting and climate policy compliance, wildfire prevention and disaster resilience, agriculture itself in order to how the crops they are and which is the information that I can get from the crops. It can be also applied to your from the smart city perspective, urban in terms of the parks. For example, here in Barcelona, we had a huge problem with water the last year, and it was about not watering. So, if we are taking this decision because we don't have water, can we know at least how the plants are, and can we water them because they are in a critical situation? So, a lot of applications, and also, of course, the part of the smart forestry, because we can know how our forests they are. Because one of the big problems is these people that are guarding the forest, they can cover all these areas that a forest it is. It's difficult to cover it properly and knowing what is happening. If we can provide them more information, the efficiency and how they are going to interact with the forest itself will help also to conserve the ecosystem. So great applications, great impacts. The idea is, I hope in 1 year we will have something to show in terms of proof of concept. But well, we are willing to keep working on this project because at the end we want to make the difference, and from the sustainability perspective, can be a huge impact on how we can use or how we can be part of the nature without without providing problems like the batteries and all the contamination and carbon footprint that can happen. So at the end, I think that the co-sentinel can be seen as from plants to digital guardians of the biosphere because they can provide us the information in order to humans help us because you know us, we can't walk, we can run, so help us because there is a fire, we need water, take care of us because it's a very important relationship, the part of the nature and the part of the humans. And thanks for listening. I don't know if I'm on time. I think that more or less I achieved the timing. So thanks for listening.
Thank you very much for that presentation, Alan. I'd like to invite the audience to type in any questions that you might have, or if you want to ask your questions directly, please raise your hand, and I will then you can address your question directly to Alan. Okay. Yes, Raymond.
Yes, thank you. That's very interesting. I was wondering if weather conditions do you plan to test how robust the signals are under different weather conditions? There might I wonder if there's some kind of distortion that may occur depending on whether it's raining or sunny or maybe seasonally as well in winter. Thank you.
Correct, correct. One of the things that we are looking with the project consortium is how the shadowing is going to affect, given there are going to be trees in the middle, for example. The part of the seasonal in terms of energy is going to affect because it's not the same the dry season than the wet season. So yeah, a lot of different conditions are going to be affecting the communication. And well, as soon as we have more or less the components working, we will move to the plan to the test plan in order to see the different conditions. That's why, for example, the non-waterlogged for the energy source, because we know that not in all places of the world it's raining always, or they are dry, they are wet enough to make this technology work. So we are aiming to try to arrive at least to big part of the world because the conditions are going to be very important, of course.
Yes, thank you.
Okay, thank you so much, Alan. So at the moment, at the current state of the project, I want to know first, how long is the project going to run for?
The project is 3 years. We are within the first year. Thanks to be talking a lot during this first 10 months. Now we are heading to a experiments. We have done designs for each of the components, and now we are on the phase of testing each component separated, which is amazing. And at the same time, it's kind of, come on, I want to put everything together. But we are on the moment of testing each of the components to make them work separated, because we think it's very important to the energy source is working, the antenna is working, and in January, February, we will start putting all together in a plant. We have to select the plant species that are the best for, or we think, because it's all about thinking, we think they can be the best for for this first test for the proof of concept because thanks to the concept of the or the methodology that we have proposed, we have different cycles. So as soon as we test this first proof of concept, we will go back to the roots, never better said, to the fundamentals in order to see what we thought in theory is happening in the practical, in the empirical side. And from here, we will do another iteration in order to test each of the components with the improvements, the going deeply on the optimization, and we will go for another proof of concept, and finally at the end of the project we will find the third proof of concept. But now the moment that we are is design each of the components and do the first experiments.
Okay, that's very, very interesting. So at the moment, what challenges do you expect along the way?
The first challenge is how we are going to attach the antenna to the leaf and make it work properly. That's the first thing because the alloy was the very first experiment in order to see that it's possible, it's feasible, and it's good working in terms of working because we double the efficiency. So how we are going to attach it? The part of the energy source, the root blocking is something challenging because the plant itself can break the energy system. So this is important, and how we are going to keep the water or keep the soil moisture in order to, even if it's a dry season, we can keep getting energy from this process. And from the radio communication system part, can we really, with the very low power, wake up systems and communicate them each other and without wasting the energy that we have been fully working in terms of it's very difficult to get the energy given the process and the amount of energy. We can't waste it. So can we aim to not misuse this energy? So these are the challenge now, and they are working in separated phases. But as soon as we come all together, will be well the big challenge. January February is going to be a very interesting period for the project.
You mentioned a lot about energy. So does the energy both have an external and an internal source? Does the energy come from the plants, or do you also provide an external source of energy?
The idea is just internal. The plan is just the plant, just the forest providing the energy from their photosynthesis. So at the end, we are going to get the energy from the sun, but in another way. We are going to get from the photosynthesis all this process with the microbes, with the resource deposition. So we want to get this energy from the soil in order to provide the energy for the radio. We will see if it's possible with just this energy, but that's the objective of the project. I think that given the first numbers that we are managing in terms of the radio, in terms of the energy, we think it's going to be possible.
I see. And what kinds of information do you think can be gathered once you've set up the system already?
We have the most dreaming objective in terms of sensors and the most normal ones in terms of temperature, humidity, but also we were thinking if it was possible a phenocam, in order to see the greenery itself. So you have information about how green is the forest, how green are the leaves. So we have the most simple ones, but low power requirement. And if we make it and we can, a phenology cam in order to see how green is the forest, and we can get a lot of information from there because if it's green and then it turns to red, something very bad is happening, and we can activate all the systems in order to save the forest.
I see. Really interesting. Are there any other questions from our audience? Okay, I don't think there are any other questions. So thank you so much, Alan, and we wish you all the best in the coming years. We're looking forward to a very successful project, and hopefully we'll get you to talk again once you have results or maybe at the end of your project. I'm sure everyone is looking forward to knowing what happens after this.
I have to say that there is a huge possibility that I will be there in the next years because we got a project granted with you with the La Salle University. It's the bridge project. I think they are finally closing the little agreement things, but I will be part of it. The principal investigator is my colleague Joan Navarro, but I will be part of the team. So I hope that thanks to this project, we will be able to meet each other in person,
Yes.
and I hope I will be able also to provide you new information and explain you how the project is in terms of communication and these things. So I hope that we will be able to see each other and share with you all this the new project, the Bridge project, and also from the CoSentinel perspective.
Okay, we'll look forward to that. Yes, please keep us posted should you be in the Philippines or if you have any upcoming talks regarding updates of your project.
Perfect. Thank you. I will.
Okay, so thank you so much. Now I'd like to present our certificate for our speaker.
Thank
Okay.
you.
We would like to present our certificate of appreciation to Dr. Alan Briones for being our resource speaker in grateful acknowledgement of his valuable contribution in the LaSalle Sustainability Lecture Series with the topic Ecological Sentinels. Given this 29th day of October 2025, signed Professor Alvin Colaba, Director of the Center for Engineering and Sustainable Development Research, and Professor Raymond Tan, Vice President for Research and Innovation. So please hold for a while so that we can take a photo. Smile. Okay, thank you very much. So again, thank you to all our participants today, and I really hope that you get to join us in our next forum. But before that, we'd like to hear from you. Kindly give us your feedback by going to the link or by scanning the QR code. Thank you,
Thanks everyone for
everyone,
listening.
and have a great day ahead, and have a good evening if you're here in the Philippines.
Thanks. Nice
Thank
to
you
meet you.
again. Nice
Bye
to meet
bye.
you and hope to see you in
Hope
person.
to see you.